Hello everyone, we're going to be answering the following question. It states to classify the following bonds as ionic, polar covalent, or non-polar covalent for each of the following cases. In the phosphorus-chlorine bond in phosphorus trichloride, the carbon-sulfide bond in carbon disulfide, the carbon-hydrogen bond in methane, and the aluminum-fluoride bond in aluminum trifluoride. So in each of these cases, let's go ahead and kind of go over what is an ionic bond. We know an ionic bond is the transfer of electrons between a metal and a nonmetal. This is going to be facilitated by the electrostatic attraction between the two. We know a polar covalent bond is a covalent bond. However, the electrons are shared unequally between the two. And then we have a nonpolar covalent bond, which the sharing of electrons is equally shared between the two atoms, or between the atoms. So in the first case, we have phosphorus and chlorine. We know where phosphorus and chlorine lies on the periodic table, and we've gone over what the relative electronegativities are, which corresponds to each of those atoms. And we know the phosphorus-chlorine bond is going to be a polar covalent bond because chlorine is going to be a more electronegative atom, and so it's going to pull and try to have that electron reside more so in its electron cloud, and so this is going to be a polar covalent bond. Remember, electronegativity increases as you go from left to right across the periodic table, and increases as you go from the bottom to the top of the periodic table. So that's important to note for the electron negativities. So let's go ahead and do the carbon-sulfide bond. So if we look at carbon and sulfur, we know as you go down the periodic table, the electronegativities decrease, and the further left you are, you also have a less electronegative atoms. So carbon and sulfide are going to be a non-polar covalent bond because the electronegativity difference between the two is roughly the same. They should both be around 2.5, give or take. So this is going to be my non-polar covalent bond. In the case of phosphorus and chlorine, they were on the same row, the same period of the periodic table. So we could really understand that as you go from left to right, the electronegativity severely increased in that scenario. In the case of carbon and hydrogen, we know they're both non-metals. So we automatically know we're going to have some type of covalent bonding between the two. And the electronegativities really between carbon and hydrogen are not very large. So this is also going to be a non-polar bond. So non-polar covalent bond. Lastly, in the case of aluminum and fluorine, so the aluminum fluoride bond, we know aluminum is a metal and fluorine is a non-metal. So right off the back, we know this is ionic. And if you kind of want to go based off of the differences in electronegativity, this one's going to be greater than 0.9 to 2. So it's really going to be larger than 0.9. So the difference in this electronegativity is going to be significant in this case. And when you have a difference in electronegativity that's greater than 0.9, it's an ionic bond. Well, please make sure you understand the trends across the periodic table, because this is really going to help you identify whether or not these are polar, covalent, nonpolar, etc. You don't need to know all of the electronegativities associated to it. However, I highly recommend knowing just a small area over here, including hydrogen, the electronegativities associated to them, because it's just going to make things a lot easier. Thank you for listening. Have a wonderful day.